Hello, Keith Rucker here at VintageMachinery.org. So just what we need, another good project to work on. We got several things going on right now, but this is one that's kind of gotten put up close to the top of the list just simply because it's a project the museum needs and needs to get done fairly quickly. It's not a huge rush, but they want to get this done as quick as possible. So what have we got here? This is the gearbox off of a hand crank blacksmith blower. So the museum, of course, has a historic village out here from roughly dating from the 1890s, 1910 time frame, with, you know, farm, a town, a sawmill, and of course a blacksmith shop. You know, the blacksmith was the mechanic of the day, pretty much the guy that you took anything to that needed to be fixed or what have you, and he was a very important person in any town of that time frame. And of course, in a blacksmith shop, you have the forge pan where your coal's burning, but in order to get the coal hot, you have to be blowing air through there. So they had these little hand crank blowers that you could just crank, and through a series of gears, that motion of turning the crank at about a speed like this would turn a fan inside that blower that would then, you know, provide the air for the forge. Well, this is the blacksmith blower that the museum has had for many years, and they started having problems with it in a couple of different ways. But one thing is that the gears have been kind of stripping in there, feeling like they're stripping when they're turning it. So we took this thing apart, and as you can probably imagine, for a piece of equipment that is as old as it is and has seen as much use as it has, you know, the museum's been in operation here since 1976, and this blower was probably old and near about wore out before they ever even started using it out here. So it's seen a lot of use over the years. So I'm going to zoom you in here, and we're going to kind of go through this gearbox and show you some of the issues that we got and what we're going to do to fix it. So this is the gearbox itself, and just to kind of give you an idea of how this works, you know, this would be on the outside, and there would be a crank on this stem here, and as you turn this, it would go through a series of gears in here, going from a large gear to a small gear, which is then on another large gear with another small gear, another large gear, another small gear, and basically it's speeding up the shaft. So for every I don't even know what the ratio is, but every time you turn this handle over here one revolution, it's turning this shaft on the inside many revolutions, and of course that's turning the fan that powers it. So what's going on here? Let's kind of dissect this thing and see if we can get this where you guys can see it a little bit better. All right, so we've got this kind of partially ready for disassembly, but this is just a housing that kind of holds all the gears in place, and I'm going to lift it out and try to lift it out. All right, so what you see here is you see the big gear in the back. It goes to a small gear on the behind this gear, which goes to another larger gear, which goes to a small gear behind here, which you can see, and that goes to another big gear, which goes to this small gear. And again, each time you're doing that, you're speeding up the revolution. So, you know, this is back gear, you can see is turning real slow, and this gear here is turning relatively fast. And then you've actually got another gear, small gear here, that's giving you even another speed increase. So there's quite a bit of mechanical advantage in here and quite a bit of speeding up. So what's going on? First off, all of these little spindles that these gears are on, they go through you know, this piece here, and then on the other side as well. It's just cast iron rubbing on steel, which actually is not a bad bearing material. We've talked about that in some of my videos before. But over the years, these shafts have worn down considerably undersized. And tell you what, let me pull these out. And this is the big gear. And look right here. See how much that's just completely worn down. And even on the other side that goes to here, this is actually worn down undersized. So all of these shafts have got issues. They're all basically been worn down. They all have got, you know, a good bit of play in them, and the shafts themselves basically need to be replaced. Now additionally, when you look at the gears, these gears, you really can't see it from the end, but if you look down on the top here, this is almost a knife point at the top of these gears. These gears are worn about halfway down, and again, there's a little lip here on the end, so when you look on the end, it doesn't look terrible. Same with the bigger gears. They're considerably worn, and in the case of one of the gears in here, we've actually got some teeth that are kind of broken out of these gears. It's not enough that it's causing it to completely quit working, but you kind of get a skip in there every now and then. So, what are we going to do? Well, we're going to completely remake all the shafts, and while I'm at it, I'm going to go ahead and completely remake all these gears as well. And I've just decided, yeah, we could probably salvage some of these and keep running them a little bit longer. Some people have talked about you can flip them around and kind of get another good side on the other side, but these things are so worn. I really want to do a good repair that's going to last, you know, basically for the rest of the life of this tool, and for many, many years to come. So the way these gears are done is the small gear here is actually built directly into the shaft, so it's actually turned onto the shaft, whereas the bigger gear is then pressed on there. And I haven't pressed any of these apart yet. I can tell that's two parts to see how these are keyed or what have you. We're going to be looking at some of that, but we're going to be basically remaking the whole gear train in here, and additionally all these bearing points in here. I came in and mic'd these. They're all a little bit oversized. Most of the wear went into the shaft rather than into the holes. I guess this cast iron was a little bit harder than the material that the shaft turning in there, but they're also not, some of these are kind of egg shaped. So what I'm going to do is we're going to actually take a reamer and ream all these out just a little bit oversized. Not very much, but enough to just kind of get a good true surface in there that's perfectly round. And then we'll machine our new shafts, our new spindles and everything to fit the new holes that they're going to go into. So that's the game plan. Let's tear in this thing and get to work. We're going to start by going ahead and getting these bearing holes that the shafts run in reamed out a little bit oversized. So originally these were 7/16, which is 0.4375 in decimal inches. And what I did was I did some measurements, and I kind of determined where we were at in here from the standpoint of where the current measurement is. And it was only a couple of thousandths oversized. So I ended up getting a reamer that is 0.445, which is about 7.5 thousandths larger than the original hole size. And the idea here is we're going to come in, we're just going to ream this out just a little bit oversized, and it'll true these holes up, and we'll have perfectly round holes. It should follow the existing hole. We're not taking much material out at all, but this should give us enough material, or take out enough material to have a good bearing surface. So this is cast iron, so I'm not using any lube. I get questions sometimes, how come you lube some things and you don't other? Generally when I'm working on cast iron, I don't use any lube. It just makes a mess and it's hard to clean up, and cast iron really doesn't need a lot of lubrication, generally speaking. Now I've got a stop over here. I don't want this to catch and spin, so I've got a stop over here that I just kind of put into the table to give me something to rest against. And we're going to come down and again just very carefully ream these out oversized. The center hole in here was originally 3/8, 0.375, and what we've got here is a 0.38 reamer, so it's about 5 thousandths larger than the original, which again should give us plenty of, should clean it up and give us something to work with. Alright, so now we've got the actual gear housing in, and this is the part that the handle comes out that spins, that turns everything. And this part was probably the worst worn of all. It was originally 11/16, 0.6875, but we're going to actually ream this out to 3/4 of an inch, 0.750. To give us plenty of material, or to get it cleaned up. I think it's going to take this much. So I got a 3/4 inch reamer, and we'll just run this down through there. And that looks like it is cleaned up all the way around. That looks good. So I've got this gear here, and what I want to do is I want to press the larger gear off. The smaller gear, like I said, is actually built into this shaft, the spindle. But this is pressed on there. I'm not sure how it's keyed in there. We're just going to try to use the arbor press to see if we can do this. Hopefully we can do it without having to go over to the hydraulic press. I'm going to put a little block in there just to kind of make sure we got good coverage. And let's see if we can press it off. Looks as though we're going to have to take it to the hydraulic press or put some heat on it or something. Over on the hydraulic press now, we're going to have a lot more force on here. Hopefully this will come right out. And I'm going to use it in manual mode rather than using the air power stuff, because I want to have a feel for this. I don't want to get too much pressure on this. You know, something like broaching, that air function is nice because you're just really trying to put a constant pressure on here. This, and with something like this a little more delicate, I don't want to get too much pressure on here, and I can feel it with this handle. So we're going to put some pressure on here and see if we can press this on out. And there it goes. So I've got the first gear part here, and as you can see, again, this is all one piece here. This gear is actually built into this spindle, and the larger gear is pressed on. This is steel. This part of the gear is all steel. Not exactly sure what grade it is, but this right here is cast iron. And that's real typical on gears. With gears, you typically want to have both of your gears of a different hardness, or sometimes even a different material, and that will really help with the wear on the gears. They're both the same hardness. They don't wear exactly right, and really you want your wear to be on one piece and not the other. Ideally. So anyway, with the cast iron and steel, we do have two different hardnesses, and also, just like cast iron is a good bearing surface on steel, you know, you get some natural lubrication even between the cast iron and the steel gear here, similar as you would where the shaft is just turning in a cast iron bore. It just runs better. So our replacement parts that we're going to make for these, it's going to be the same thing, steel and cast iron, and we'll show you that in a little bit. But basically, the shaft is going to be made out of some I think 4140, the chrome moly steel, which is was recommended to me for a material for turning gears. It's real tough, real wear resistant. But you know, but strong enough for gears. And then these bigger gears will be made out of some ductile cast iron. I just got some bar stock of ductile cast iron, and we'll saw them into pieces and then machine them out. All right, so we got everything apart now. So this gear doesn't have a big gear on it. This one just goes straight to the fan blades. All of these, this is of course the one with the handle, it just has the big gear on it. and these two both have a big and a small gear. I will note that this gear here, for whatever reason, instead of being made out of cast iron, this is some type of, I'm not sure what kind of material this is. It's either a resin or a phenolic type material, you know, who knows, but it's not metal. It's some type of man-made material, and quite honestly, this is probably was the biggest downfall in this whole project as far as the gears being stripped off of it. We've got several teeth in this gear that are just completely stripped out. A lot of the other ones are worn bad, but this is really the main culprit. And I'm going to replace it with a cast iron gear. I don't see why it couldn't be. Again, I imagine this was just something to save a few bucks, even back when this was made. This gear was pinned in place. There was a pin that came in at an angle, and I saw the hole up here in the top, but it didn't click to me what it was. But this was a tapered pin that goes through there and actually pinned this gear in place. And of course, when I pressed it out, it just pushed out through this material that's kind of soft. But again, we're going to replace that with a cast iron gear. And I think what we're going to work on now is start making the individual shafts. So I'm getting ready to start over here on the lathe, but before I get started, I'm going to mention I'm trying a new insert here. I've been playing around with some different inserts, and you know, with this chrome modeling material, it's pretty tough material. So I did a little inquiring. I talked to Adam Booth, who I go to for a lot of times on this kind of information, and he recommended this ISCAR insert here. It's a CNMG, I don't know if you can read that, CNMG 432-TF, and the grade is an IC 8350. And that's what I'm going to be using here. I ordered me a pack of these. They're not real cheap, but you know, if they do a good job, so go for it. So there's four. I think I ended up paying about $10 a piece for these inserts. Adam says he can get them for about $7.50. I couldn't find them quite that cheap anywhere. But you got 4 surfaces that you can do, because you can flip it over and there's 2 on each side. So anyway, it's not too bad. These should last me for quite a while. But we're going to go in here and start by facing this off, putting a center in there, and then we'll turn it down. All right, we're getting real close to being done on this side, but there's two more things that need to be done. I don't know if you can see it or not, but there's a little bit of relief behind this and these two pieces right here. So I've got a little parting tool in here that's the right size, and I just need to go in there and just cut a little bit of relief back there. I think that's for some oil to kind of gather in. It gives a place for the oil to kind of get around that shaft a little bit. So I've made some measurements, and this is where I'm going to also clean up this inside shoulder to get it where it needs to be on both of these. Because if you remember, I did purposely left it a little bit long. So I've measured, you know, my original one here, and I've measured this one, and I've got about 65 thousandths I need to, more than what's there that I need to take off. So I'm just going to come in here, I'm going to touch off on this, we'll measure it again, and then using a dial indicator, we'll get that measured out. So I'm going to come over this shoulder, and I'm just going to touch off on it right there. I'm going to go in and make a clean shoulder. All right, now I'm going to get a good measurement on that. To get that where it needs to be. So I'm going to take my dial indicator now, and we're going to put it down here on the carriage. I'm going to zero that in, and I'm just going to read out 55 thousandths right there. We're going to come in, and this will form that proper depth of the shoulder. I'm going to go just a little bit deeper to give an oil groove there. Tell you what, let me bring that center in here, give me some support. And that's probably good. I went just a little bit below flush. Let's get a measurement, make sure we're where we need to be. Right where we need to be. All right, we're going to do the same thing here. I'm going to come in, I'm going to clean up this shoulder, get a good, nice, clean surface all the way down. Now I'm going to get a measurement. I need to go in 80 thousandths to get that proper diameter. So again, using my dial indicator, I'll go in 80 thousandths and make our cut. Sorry guys, you missed the cut, but I basically just went in here, went down to depth, and measured that little indentation in the back, and we're right on the money. So I'm going to take a file and just hit these corners in here while I've got everything spinning. So you can see now we've got basically the one side of this shaft turned down. All these measurements are to the right measurement. Of course, we still have to put the gear teeth in there, which will be in a later step. So now we're going to go ahead and lop this thing off and just take it to the bandsaw, and then we'll go ahead and turn down the little bearing spindle on the other side. So now we need to turn this little bearing surface on this end down. Of course, this will be where the gear's cut. And I flipped this around. I've got it in a forge-jaw chuck now. I've got some little protectors here. These are just some brass or copper strips or whatever to keep from marring up with the hardened surface directly on that area we're going to press on. So we got this running now within about a 10,000th of an inch, and that's probably about as good as you're going to expect to get anything out of just a regular chuck. So anyway, we're going to go ahead and turn this in, and we'll have this shaft ready for gear cutting. getting real close here on this diameter, so I'm going to come in here with my mic now. And we still got about 10, 11 thousandths to go. All right, we're within about a half thousandth where we need to be. So let's go ahead and finish getting the rest of these dimensions right, and we will polish it up. As with the other side, there's a little bit of a groove down here in the bottom, and this is a little bit long, so I'm going to just face it off, and we'll get a good measurement on that, and then dial it into where it needs to be on that length. So we need to go in about 15 thousandths here to get that right. So I've got my dial indicator here, and we'll just move the carriage in 15 thousandths and make another pass up here. And the last thing we need to do here is just polish this down to size. We're about 5, 6, 10 thousandths of an inch over right now, and we want to get this down pretty close. We're right on the money right there. All right, so here's the original part that we've been copying. Here's a new part. All my measurements are in tolerance. So these journal ends are about 3 thousandths undersized what I've got it reamed out, and I've test fitted them, they fit good. And this piece here is about a thousandth and a half, I guess, actually oversized where that gear will press on there. And of course, we've still got to cut our gear teeth on this one, and that'll be coming up probably in a later video. We're going to get all these shafts made first. So this gear will fit right down in here, goes in there, and it'll spin against the bigger gear coming out of the handle. And let's see, and it'll go on that one there. So everything appears to fit good. We should be ready to move on to the next piece we want to make. All right, second gear blank all knocked out. As you can tell, this original gear here is also worn very thin. It's not quite as much of the sharp edge there, but not very far from it. But that one there is all within tolerances, and it's ready to have the spur gear cut on it as well. And this gear will fit right here. There we go. We made the couple of these other shafts off camera here, but basically we have all of them done now. So these three here, you know, we have blanks in there where gears will be turned, and then this one, and this one will have a big gear pressed on them. So this one here only has a big gear, and this one here only has a small gear, and this will be from the hand crank is on this end, driving a big gear, which will then drive this small gear, which will drive this big gear, which will drive this small gear, which will drive this big gear, which will drive this small gear, and this one here will drive the fan. So obviously you're getting a nice speed increase from the hand crank on this end to the fan turning on the other end. So let's see if we can kind of dry assemble this, at least get the shafts in place. Obviously we won't have the big gears done or the gear cutting done on these, but we get an idea of how all this fits together. So again, we have the housing here that holds all the gear train. And the first one we're going to put in is the one that goes through. This is one to be that the hand crank is on. And it'll have a big gear that fits over it in here. Next will be this one here. Up next, this one here. Again, the big gear meshes with the small gear. And then the final gear is the one that drives the fan, and that one fits on here, right here. And there's this little piece here that holds it on the bottom. A couple of screws that hold that in place. And then all this fits on top. There we go. So I like the way that's dry fitting. And now we got to work on the big gears and get these spur gears cut on these. So here are the finished shafts and with the gear blanks on it. Next step is come in here, get out the dividing head, and we'll go ahead and start cutting the gears on these three blanks right here. And we'll be getting on that part of the project real soon. So that'll wrap up this episode, guys, and like we just said, we're going to get the dividing head out and start doing some gear cutting here. Excited about doing that. Haven't cut any gears in a long time, and I'm really looking forward to working through this project with you guys and showing you some gear cutting on the horizontal mill. So that'll be coming up very soon. Thanks for watching. We'll see you later.